here's a problem that's like that MyMathLab problem. So they went out and they did a random sample, which is important. So let's just use these tricks, these techniques, and to find the best estimate. Well, since we don't know the populace, we don't know the proportion of adults who think the government should get involved with global warming. They said out of 1,708 people, 939 agreed with that statement. Okay, so our best estimate is going to be that proportion. So, and because this is coming from a sample, I'm going to use p hat to represent that, and that's going to be 939 divided by 1708. And whether you want to talk about that as a percentage and multiplying by 100, that's up to you. You know, you'd have to worry about MyMathLab's what they wanted. So if I find that decimal, I see that that's about equal to, and I'm going to do some rounding here. Let's see, 0.5. I guess it would round to 550. Okay, and then to construct a 95% confidence interval for the proportion of adults. Okay, so what we're going to do is we're going to find the margin of error. So to do the margin of error, we do 2 times the standard deviation, and because this is a proportion, we're going to use that 2 times your p hat. That's p hat times 1 minus p hat over the square root of n. So I'm going to substitute in these values. So 2 times the square root of 0.55 times 1 minus 0.55 is going to be 0.45. I'm going to divide that by the sample size of 1708. So I do the multiplication here first, get that answer, divide that answer by 1708. Then I'm going to take the square root of that and then double it. So after I get through all that, I'm getting, let's see, I need a pen, 0.024. I'll go 3 decimal places since I have 2 really. So now to calculate the interval, I'm going to take the 0.55 minus 0.024 and 0.55 plus 0.024, and those are going to be my upper and lower estimates for what the actual percentage or proportion of people who think government action is needed right now. So let's see, can I do this in my head? It's 0.574, and then we're going to subtract that. Let's see, 3, it'd be 53, 52.6 if I'm thinking correctly. Okay, so that would be B without writing any kind of confidence statement. So I think when you're writing confidence intervals, it's important to make some kind of, instead of just writing the raw numbers, it's better to write a statement, a confidence statement. Some other books talk about this, but and this trial book does too. But so what I just found was, and I converted those numbers to percentages, that the actual true percentage of adults who think the climate and government action is required is between those two numbers. And there's a 5% chance I'm wrong, because I'm at a 95% confidence interval. There's a 5% chance that I actually missed the true percentage. But that's what a confidence interval is doing. We're trying to estimate, calculate an unknown percentage, and I don't know what percentage the actual of the actual population support this. So that's what B's getting at. And when you go to MyMathLab and they ask you to choose one, you want to be looking for things like this. They'll say we're 95% confident that the actual average or the actual percentage falls in between that interval. Okay, and that's how you deal with that. Now for part C, it says that we were trying to show that is there more than 50% of the people that support this? Well, 50% falls outside that interval, and we know the chance of that happening is of getting a value that's outside of that interval is only a 5% chance. And what we're going to do next week is actually come up with a way to calculate that percentage. Right now we're just guessing. So yeah, I would say based on the sample that higher than 50% of the people would support this or think this, and that's how you draw conclusions from your constant interval. If the percentage you're looking for, or the mean, even when we deal with means, if that's outside your interval, you can say something's happening more than just chance variation coming from samples. Okay, so I hope that helps.